Hello, everyone. I hope you got a chance to get out and enjoy the snow today a little bit. So I'm going to keep this one very short. I just want to mention a little bit more about the final exam. I'm not going to give like a thorough comprehensive view today, but I'm going to show you what might be the best strategy for you to do. And then at the end, I also just want to give a quick little example that I wasn't able to get to last Wednesday. So just to recap again, I've mentioned this a few times, just make sure everyone's on the same page. The final exam is running between December 13th and 15th. It's going to be posted like first thing in the morning. So 0 hours on Monday, December 13th, and it's going to run to 23:59 Wednesday, December 15th. And you've got 6 hours to take it. So the exam window is going to close at 23:59 on December 15th. So don't wait until 23:00 on the 15th and expect to have the full 6 hours. It's going to shut you out. So you want to make sure you start it at least 6 hours in advance of this if you're going to wait till the last day. So again, the final exam is cumulative. So anything from lecture and lab are fair game, and it's 20% of your final mark. You have 6 hours to attempt one attempt. You don't get repeated attempts on this like you have with your labs or anything like that. So it's just one attempt. And unless you encounter extenuating circumstances like, I don't know, power outage or something like that, I'm not going to open it back up for you. If you have extenuating circumstances, you can contact me and we can sort something out. But otherwise, yeah, you just get one 6-hour attempt. If you have a letter from Access and Diversity and you need more than the allotted time, you can contact me anytime before the exam starts, and I'll just change the time window for you. So spent the weekend writing the exam. I'm not quite done with it, but more or less got it sussed out. So I just want to give you a little bit more detail on what you can expect from it. So essays are going to be the bulk of it. You're going to have 3 essays. So you're going to have to answer 1 on coordinate systems, 1 on data models, and then 1, you're going to be given a choice of something pertaining to error or pertaining to ethics and positionality. So you'll get a choice on that one. Then the next chunk is going to be a single flowchart question that's worth 20% of your grade. And so you can create a flowchart, either drawing it out by hand if you want, and take a picture and upload it, or you can make it in like PowerPoint or something, or you can use the tool that I suggested everyone folks use for their final projects. It's pretty quick and easy to use. There will be a link to that embedded in the actual flowchart question, so you don't have to like memorize the link if you want to try that. And so this question is intended to demonstrate for you to demonstrate your understanding of tools and processes and how you actually go about laying out a workflow. So this is assessing your comprehension of the lab material a lot. Now, I had mentioned that there would be a GIS task question. I've decided to nix that. That way you don't have to be physically in the lab space or have any connection to ARC to take the exam. So for those who may have been concerned about that, I've dropped that portion of the exam. And then it's going to be about 20% short answer. So that's just going to be assortment of miscellaneous topics throughout the term. And then 1 point will be some map critique question where basically I'm going to present some maps and ask you to discuss some things about it. So, you know, might want to reference the visualization lecture for that. And then to round out, there will be some fill in the blank, matching, multiple choice, maybe true false question or 2. The fill in the blank questions will be reviewed just as they were have been for the modules. So like, you know, if you make a typo or something, like, you'll be fine. I'm not gonna penalize people for spelling something wrong or anything like that. So we'll go back and review those questions. So just a little bit more information. Again, if you experience any extenuating circumstances, you can reach out to me, but I'm not going to answer any questions related to the content of the exam during the examination period. Further, don't contact your TAs about anything during this period. They're just not going to respond to your emails. So any serious issues, you can contact me, but beyond that, you're on your own. And yeah, the exam is open book, which means you can reference any resources that we've gone through in the class, or anything online to work through the questions. That said, everything you put in this exam must be in your own words. Don't copy and paste anything from the internet, no resources from elsewhere, no lecture content, no lab content. I mean, especially if you copy my lecture content or lab content word for word, like we're going to notice that. But also, broadly speaking, if you copy and paste from Wikipedia, that's going to get noticed as well. And plagiarism is going to be taken very seriously. And if there's any instance of it, it could result in you failing the exam. So again, you can reference the resources, but put everything in your own words. Type it yourself. Don't copy and paste from the internet. That's going to get you in trouble. Further, you can't work with or copy the work of any of your other students. This is also plagiarism and again would result in serious issues. So beyond that, questions, including the essay prompts, are going to be randomly assigned from a question bank. So there's really no benefit in even planning to collaborate with anybody or making plans to work together because you're going to get assigned different questions anyway. So save yourself the time of trying to figure out how you could collaborate and just don't do it. If anybody submits responses that look like somebody copied one another, again, this is going to create really serious issues for it. So we'd rather just not have to approach that issue. So what I would suggest is your best approach for reviewing and thinking about how to study for this. It's open book, so you can reference anything during the exam, but that said, there's certainly not enough time to cover all the content. During that 6-hour period, you certainly don't want to rely on being able to go back and watch videos and things like that. So all the lecture videos from the in-person lectures are posted to the Canvas page. But what I would suggest you do is just review the module web pages each individually. So I said there's going to be an essay on coordinate reference systems and an essay on spatial data models. So these two are especially important, right? So you want to make sure you look through these. And so with coordinate reference systems, you want to make sure that you understand the steps of abstraction. So how do we go from, this big lumpy ball of rock careening through space all the way to a two-dimensional map that we can put into a GIS. So, just review the slides for this. And further, specifically pertaining to projected coordinate systems, how do we create them? What's the difference between, a projected coordinate system and a geographic coordinate system? What are some of the different types of projections and the sacrifices that are associated with those different types of projections? So very important things to understand. Projections are, one of the sort of foundational concepts of GIS. So it's important to demonstrate at least a broad understanding of that. Further, spatial data models are the other key concept of GIS. So we want you to be able to distinguish between them, know what the different types of phenomena are, for instance, and which data models work best for which types of phenomena. You also want to know, broadly speaking, what the different types of data are, not just strictly spatial data, but data in general, so qualitative versus quantitative, and then the different types of qualitative and quantitative, so nominal, ordinal versus interval and ratio. Understand the distinctions between them. And so again, want to know the raster versus the vector data model. So you can find a recap here for the raster model and the vector model. Also important to know first law of geography and understand the implications behind it. Don't just be able to, quote Waldo Tobler, but what does it actually mean? to say that everything is related, but near things are more related than distant things. So these two are going to be the most important, I'd say, but broadly speaking, you also want to know, for instance, error and ethics. So you'll be given a choice of, which one of these subjects you want to write an essay about. That said, there might be some, say, multiple choice questions that also pertain to the other one. So don't just choose to review module 6 and not think anything about 7 or vice versa. But in regards to error and ethics, or in regards to error, you want to understand what are the different sources of uncertainty. So precision versus accuracy, and then ambiguity versus vagueness and logical flaws. You want to have a bit of an understanding of the different types of logical fallacies. So things that result from data aggregation, like ecological fallacy. You want to know what the modifiable error unit problem is. And this kind of leads into the idea of ethics when you start thinking about things like gerrymandering and stuff like that. And then for ethics, you want to have, generally speaking, an understanding of what ethics is within the concept of GIS, specifically why it's important, what's the idea of positionality, things like that. And so pertaining to, say, module 1, the history of GIS, I'm not going to ask you to remember what date any of the old maps are from or anything like that, but broadly speaking, have just a general holistic understanding of the fact that the very Eurocentric narrative of mapping that is presented most often is not the only method, and that, for instance, cartography developed around the world separately on multiple different occasions and things like that. And yeah, regarding classification and visualization, you want to, broadly speaking, understand, again, you might want to review these videos to say, get some better idea for how you might go about critiquing a map. And as far as data classification methods go, you want to understand, say, the differences between supervised and unsupervised. I'm not going to ask you, say, to explain how any of these complex classification methods work, but you want to at least know what they are. Definitely want to understand the concept of data normalization, because that's a very important component of GIS. And then for spatial analysis and workflows, you don't necessarily need to memorize every single one of these tools, but you want to know how they work and how they can be strung together. Again, there's often multiple ways to do any one thing in GIS. So when you're presented with your flowchart question, it's not necessarily that there's one right answer. There's probably 3 or 4 different paths that you could take to get to the final result. One might be shorter or longer than the other, but that's not going to be necessarily what you're marked on. It's the shortest path, but just is what you laid out going to get you to the answer, and how do you go about doing that? And yeah, I think that more or less covers it. In the meantime, if anyone has any questions between now and before the start of the exam, feel free to reach out. I'm happy to help clarify things if you're uncertain about anything. So one thing that I just wanted to show really quickly that I wasn't able to get to last week, just in reference to some applications of GIS. We've used Google Earth Engine quite a few times, and I spent a good bit of time last Wednesday talking about how GIS can be used for disaster planning, mitigation, response, and all that. And so I just want to show a really pertinent, relevant example that's, still somewhat ongoing. So this is just a false color image from Google Earth Engine from the MODIS satellite that was taken. This one was taken on Halloween or the day before Halloween. And so you can see the Fraser Valley, and here's Sumas Prairie. And we have an image from after, or from before the storm event from November 13th to 15th. We also have an image from after. And so you'll notice there's some cloud cover here, but you'll also notice the dark areas represent water. So this is a 250-meter resolution image from the MODIS satellite. And so it's a false color image because it doesn't have red, green, and blue. It's just some light reflectivity. I think it's got red and blue maybe, but it doesn't have green. Anyway, the point being, you can notice even just on this image, it can be used to detect large-scale inundation. So you can see that Sumas Prairie is not inundated in this image, and you can see the full extent of the inundation in this image. This really highlights the magnitude, the scale of the problem. Further than that, you can see inundation in other areas, portions of Surrey and Delta, for instance, and some of the farmland over there, but the most striking is in the Sumas Prairie region. And so as more and more data becomes available from this instance, it can be used to work to map out the areas that flooded and help maybe develop better flood response plans in the future, things like that. Also, like the data is not made instantly available to the public on Google Earth as soon as it's collected, but it is available to some organizations, the government organizations, and there's even higher resolution satellite imagery that's like classified and stuff, and that imagery is often used in disaster responses. Beyond that, they also flew a number of flights and transects and collected imagery from planes and used that to say map out damage to highways and things like that. So they flew a flight all the way up the Fraser Canyon following Highway 1, for instance, to map out the regions that were impacted there. So I just wanted to make sure I showed this because I think given everything that's happened in the last month, this is a really just stark example that can highlight how geospatial analysis can be used as a tool to try and help prevent, or not prevent disasters, but adapt to and mitigate issues stemming from them.